Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video I'm going to do something completely different than what I've done in previous videos. You've heard me say on this channel before that I'm a retired computer programmer, and I still like to program some. Now, during my career, especially the last 25 or so years of it, was writing code for backroom server applications, code that had very little user interface. In addition to that, I wrote code that had a user interface but didn't involve a keyboard and mouse. It involved a telephone. But recently I've got involved in writing some GUI applications, GUI, graphical user interfaces. And I decided out here in the Tin Barn, one of my passions now as a hobbyist is the machining, is to put together some various programs, or applets if you will, into one single program to assist me here in the Tin Barn. Now I'm going to show you each part of this program. I call it Machinist Applets. It's made up of 8 different small programs, a keyboard, and all the background functionality. As much as I would like to tell you that it's available to you, the public, to download, I'm just not set up for that right now. I hope one day I will be able to. It is an executable program. And basically all the email applications, Gmail, Outlook, etc., prohibit emailing executable programs. That's the way viruses get spread. So I'll tell you right up front, this is not available for public consumption yet. I hope one day maybe I can have a web page where you can go to it, and for a very nominal donation, $5–10, something like that, you can download and use this program on your system. You've seen me in some of the previous programs use it here in the Tin Barn. Where I'm facing right now, my mill is over here on this side, my lathe is over here, and directly behind where you are in the camera now is where I had it originally mounted. And again, you've seen me use that in some previous programs. However, it was a very inconvenient location. A lot of times I'll set the camera up between the mill and the lathe, and it was just not convenient to get that. So I've moved it now to over here, right to, it's mounted above my workbench. That's a reflection you see in it right now. But this is a 10-inch touch screen. It's in standby mode right now. If I touch it, within a second or two, it should come up as it did. But it is a 10-inch touch screen, and on the back of it is, this touch screen is made for a Raspberry Pi. Let me say that. A Raspberry Pi is a single board computer about the size of a pack of cigarettes. There is a mount in the back of this touchscreen meant for a Raspberry Pi 3 or Raspberry Pi 4. It is mounted in there. It runs off of just regular wall power. It's not a tablet now. Don't confuse this with a tablet. It is a full-fledged computer running the Raspbian operating system, which is a version of the Linux operating system. But this is how I normally use this application. Again, there's 8 applets in it, 1, 2, 3, 4, 5, 6, 7, 8, and a keyboard and a set of executable or execution keys down here. This is a touch screen. I can activate the various keys on it by touching, or I can use a stylus. For today's demonstration, instead of trying to zoom the camera in on this and not making it very clear, I'm going to be over here on my desktop computer, which has got actually 4 monitors attached to it. But I'm going to be running that program on this monitor, and I'll be doing a screen capture of that. So everything you see will be me sitting at this computer, operating the very same application that's running on this little touch screen over here on the side. Okay, this is the monitor that I showed you in the introduction. Let's launch our app, Machinist Applets. I'll pull it on down about the center of the screen, make it a little easier for you to see. First off, this is Machinist Applets version 3.21. I've been working on this for quite a while, keeping a version control on it, so if I break something I can go back. But if we pull up the help, overall instructions, it says an applet is a small computer program that performs a specific task. It is typically embedded within another larger app and has limited functionality. This allows applets to run quickly and reliably without demanding a lot of system resources. Of course, there's more instructions on how to use it. The applets in this program, one is called Compound Travel. The next is called Match Imperial Threads, Match Metric Threads, Metric to Imperial Converter, Decimal to Fraction or Fraction to Decimal Converter, Bolt Hole Circle Patterns. I think you'll find this one kind of interesting. A taper calculator, and then an equation solver, which an equation solver is basically a calculator with a little bit more added to it. The first one we're going to look at is called Compound Travel. Now, what do I mean by compound travel? Here's an image a picture taken of my lathe set up for external threading. The compound is set up at 30 degrees, 29.5 degrees. The threading tool is touched off against the work. This dial, the cross slide dial, is set to 0, and the compound is set to 0. Now, I'm going to say we're going to cut 13 threads per inch. So we know how this works. We get this all set up, we engage our half nuts down here. This travels over to our stopping point, or to our point. When we get to our stopping point, we disengage the half nuts. We back the compound off, back the cross slide off, move the carriage back to our starting position, put this back to 0, cross slide back to 0, and then we advance the compound. Now the question is, when you're cutting a particular threads per inch, how much do you turn this? We're only going to move it about 4 to 5 thousandths at a time. But overall, how much do you move this? And that is what this applet does. Now notice when I select this applet right here, the numeric keypad is going to change. Some keys are going to go away. The keys that are going to go away are ones that are not needed or not used in this applet. When I click this button at the top, there's going to be a green border around this, meaning this applet is active at this time, and anything entered on the numeric keypad will transfer or will be directed toward this applet. So we choose Compound Travel. We see several of these keys blanked out over here now. Let me show you that again. See all these keys over here? We select that, it highlights it, and some of the keys were blanked out. That will do that for each of the applets. So let's take our Imperial threads per inch and choose 13. We come over here to our numeric keypad in the button frame and click Calculate. That tells us that the compound will move 58 thousandths. So overall, in our threading process, that's 10 thousandths there, 20. We'll move that until we see 58 thousandths. Now the same is true, or we got this up here, what about a metric pitch? Let's reset that out. Notice where I'm at with the mouse pointer down here. Reset that out. The out remains selected, but the data we had entered before has gone away. So if we choose a metric pitch and say a pitch of 1.5, we're on a Imperial lathe. I'm on an Imperial lathe that has an Imperial dial, but if I'm cutting metric threads, which you can on this, and I showed that in great detail in a threading series earlier this year, but how much do we move the compound in that case? So we've at 1.5 pitch, calculate, that says we move 44 thousandths. Now again, when we reset the applet, these values will get reset. When we reset all, we see the keys come back over here, and this applet is no longer selected. Okay, the next applet we're going to look at is called Match Imperial Threads. Now what do I mean by that? Here is a piece of stock that measured, I turned it down to just some arbitrary value. It turned out to be 0.631 external diameter. I cut 18 threads per inch on it, and I used a compound travel over here to tell me how deep or how much to advance the compound to get 18 threads per inch. But we've got this piece of non-nominal, and what I mean by non-nominal, it's not a standard fractional value like 1/4 inch, 3/8, half, so forth. This is 0.631 with 18 threads per inch. You're probably not going to be able to go to a chart anywhere and find those dimensions of 0.631 with a 18 threads per inch turned on it. So how do we know what size hole to drill to cut our matching internal threads? Well, let's come over here, match Imperial threads. All right, we'll make it active. Our threads per inch is 18, and our external inches we measured as 0.631. Calculate. That says we need to drill a hole 0.575. Now let's do the inverse of that. Let's reset this applet, and let's say we've got a internal thread that we use our thread gauge and determined that was 18 threads per inch, and we measured the internal and we come to 0.575. So we go match Imperial threads, 18 threads per inch, and our internal was 0.575. And I'm sitting here at the keyboard, and I can use the keyboard to put those values in, or I can come over here, and on that touch screen I would actually touch 0.575, and now we run our calculate or equal sign. They both do the same thing in this program, and that gives us our 0.631. So no matter which one you're starting with, whether you're starting with a internal thread, non-nominal internal that you need to match for an external, know what you turn your external rod into, or you start with a rod that's 0.631 or a piece of round stock 0.631. How big of a hole do you need to drill to match 18 threads per inch? So this little applet does that. The third applet we're going to look at is very much like the second app. This one's called Match Metric Threads, one we just looked at was matching Imperial threads. On matching metric threads, here's a little scenario for you. This item right here, I got from my nephew, and in that threading video series, I asked if anybody recognized this to put it in the comments, and I was surprised at how many people knew what this was. This is an axle nut for a Volkswagen. I don't remember now what model it was, but my nephew gave it to me. I measured this. The internal pitch is 1.5 metric threads, of course, Volkswagen. The diameter across this was 22.5 millimeters. Now, I looked on several charts, and as I said earlier in the introduction, you can probably find formulas on the web to do all these things for you. I just wanted to put them in an application or an Applets program. But I measured across this, and it was 22.5 millimeter, 1.5 pitch. I wanted to see if I could turn an external threads to match this internal. And that's what I mean about matching threads. So we select match metric threads. I said it was 1.5 pitch, and I measured in millimeters internally 22.5, and that told me that I needed to turn the external diameter of my round stock to the 24 millimeter. Matching metric threads is much simpler than matching Imperial threads. You see the relationship there? Internal was 22.5, pitch was 1.5. Just add the two together to get the external. Or if you've got the external value here and you want to know the internal, just subtract the pitch from it. 24 minus 1.5 is 22.5. So that was a pretty simple math. But again, it works just like the match Imperial threads, we match metric threads. The fourth applet is called metric/Imperial, and it's one of the simplest applets on here, but it's one I found myself needing and using probably more so than all the rest put together. You know your number of inches. You got 1.25. Now let's convert that to millimeters. 31.75. Again, something I find myself doing all the time. We got 36.5 millimeters. What does that come out to in inches? 1.437. Again, very, very simple applet, but one of the most useful ones on here. The fifth applet is another converter, but instead of converting metric to imperial and imperial back to metric, we can convert decimals to fractions or fractions to decimal. It says here enter the numerator or the denominator or the decimal. All right, let's come up here with a 3, and see I've got tab keys over here too. Tab, 4, calculate is 0.75. Now I think we all know most of these standard conversions: 1/8 inch, 1/4 inch, 3/8, half, 5/8, 3/4, 7/8, so forth. But when you get to some odd value, say you've got a decimal of 0.431, calculate, that's 431,000 over 1,000. Yeah, that's not that good an example. Let's try another one. Let's say you've got, again, one of the simple fractions. The decimal is 0.875. That is 7/8. Most often I will use this applet to convert a numerator denominator to a decimal value. In other words, I read something with a tape measure or a rule that's in, say, an eighth of an inch increments, and I want to convert that to a decimal value. Applet number 6, we'll call it, is called a bolt circle. Now, if you've got a DRO on your mill, there's a good chance you know how to lay out a bolt hole pattern on that using your DRO. Couple things you need to know though. You need to know the number of holes and the diameter of your bolt hole pattern, diameter of the circle. What if you're faced with a situation like this? Let's say this is the bolt hole pattern in a spare tire for a trailer, and you want to make a mount for that to haul that spare tire on. Well, we can easily see there's 5 holes that we need in our pattern, but it's being an odd number here, it's hard to find the diameter of this bolt hole pattern. We don't have a point in the center here to measure from, but we can, using our digital micrometers, we can zero them out, the width of the hole, and then measure the distance between the holes. Now that actual distance is irrelevant for what we're doing right here. But let's say we measured a distance between those holes of 2.675. So we come over here to our bolt circle, and it says the number of holes and the circle diameter or the distance between the holes. Now we know the number of holes is 5. We know the distance between the holes is 2.675. So if we calculate, that gives us a bolt hole pattern diameter of 4.551. So on our DRO, we would set that up. We would tell the DRO that we've got 5 holes and our bolt hole pattern, our circle diameter is 4.551. The DRO will do the rest of the calculation and give us the XY position to drill each one of these holes. Now the inverse would work if you knew the circle diameter but didn't know the distance between the holes. I don't really know a practical use for that. However, these 3 variables had to be in there, so I just went ahead and did the reverse of that as well. If we reset that out and we go 5 holes, and we know our circle diameter is 4.551, that's going to give us the 2.675. Again, these are just arbitrary values. The next applet we're going to look at is called taper calculator. Now, I think most of you probably understand that each one of these individual applets started out as a standalone program, most of them anyhow, and I later put them together in this one program called Machinist Applets. The taper calculator one is probably one of the first machining programs that I wrote, or program that I wrote relating to machining. Let me show you a couple of samples of some tapers. This is from a video I did a couple months ago where I was showing how you could do a knurling on a taper. But this taper was turned on the lathe. Here's a Christmas tree that was turned on the lathe as well, using what we learned in that video on knurling a taper. And then this one is made out of food grade stainless steel, and it's a cutter the actual cutting blade that goes in my sweet corn cutter. Let me show you just a quick little clip of it in action. As you can see here, I'm set up in the tin barn. I made a video on this a while back, but that cutter is right here, and it's cutting the corn off the cob. Cob is falling through. Now, to cut this, to make this cutter knife edge thin at this edge, but much thicker down here, we needed to set that up in the lathe. And this is the way it was set up. We will be advancing on the workpiece through the use of a compound set at an angle equal to what I want the angle on this to be. So the question is, what do we set the compound angle at, or how do we calculate that? Here's a quick drawing. The cutter part of that piece, the cutting edge part of that piece, is 1.5 inches large diameter. Remember that, 1.5 inches on the large diameter. It's 1 inch on the small diameter, and the length of the cut is going to be 1 inch. So how do we calculate what angle to set the compound? In this applet right here, remember we said the large diameter was 1.5, small diameter was 1, and the length of the cut was 1. One and a half for the large diameter, 1 for the small diameter, and 1 for the length. We calculate. That says our compound angle should be set at 14.04. So this was set at 14 degrees. Now, as this says, you can enter any 3. So there may be a situation where you know the large diameter, 1.5, or you want to calculate how long a piece would be. So let's say large diameter 1.5, and let's just say our small diameter, the point is going to be 0.75 inches, and we want to set the compound at 12 degrees. So how long of a piece are we going to come out with? 1.79 inches is what it's going to take. So as it says, we enter any 3 of these values, and the 4th one will be computed. The final applet we're going to look at is one called equation solver. Now, what's the difference between an equation solver and a simple calculator? Well, we'll get to that part in just a second, but let me show you how it does just simple math. 25 plus 6 equals 31. We have a window here that also shows us what equation that we put in. 12 divided by 3, 4. We can do simple math. 2 plus 2 equals 4. So that's just a simple calculator, and I'm sure most any computerized device you got, whether it's be a desktop computer, a tablet, a smartphone, or whatever, has a calculator built into it. But I wanted something just a little bit that will allow just a little bit more functionality. I got into a little bit of trig here with the square root function, but I didn't do a whole lot. I have a trig calculator if I need to calculate sine, cosine, tangent, and those kind of things. But I did want something that would do just a little bit more than basic math. Here's a fixture plate that I recently made. Now, if I was going to do something like this again, I would need to know, or want to know, the length of the piece of material that I needed to start with. In this case, I wanted to have a 1/2 inch between the center of the first hole and the edge. Then I wanted 3/4 of an inch between each hole. And I wanted 12 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I wanted a 1/2 inch at the end of it. So how can we quickly compute what the length of that is? Now, if we count our spaces between these 12 holes, we'll find that there's 11 spaces between the two holes. So there's 0.5 at this end, there's 0.5 at that end, and there's 11 3/4 inch spaces. So we can come down here and we can say 0.5, that's what we wanted to start with, plus, open our parens and say 11 times 0.75, and close our parens, plus the 0.5 we want at the end. Oops. 0.5. So this gives us our 1/2 inch at the start of the piece, right here. This plus 0.5 at the end will give us this space, and the 11 times 0.75 is these 11 spaces in between the 12 holes times the 0.75. If we calculate that, that says our piece should be 9.25 inches long. And here's our whole equation up here if we want to review back. Now, I totally realize that you could multiply 11 times 0.75, set that off to the side, and then add to it 0.5 plus another 0.5 and come with that. But an equation solver is just allows you to put it in and honor the order of execution by using your parens. Another thing, the equation solver, another thing I built into that, let's say 1 divided by 3. There's 4 decimal places. Now, we may want a particular operation that we're fixing to do, or equation we want to solve. We may need a different amount of precision. So we can come up here, set that to 8, which that means 8 decimal places. 1 divided by 3, and we see that it carries out to 8 decimal places. A couple other features that I built into this was square root. I don't use square root a lot, but if we put a number and hit the square root symbol, we get the square root of it. I don't use it a lot, but it really, in all honesty, is a filler for this spot right here. I had the keyboard laid out and I needed something to fill that spot. A practical one here, let's say we want to get half of a number like we do on the DRO on our mill, all the time. We're always using the half function. But what if we're setting, what if I'm sitting there at the workbench? I can easily, I can go 15.653. Let me write that down, 15.653. And if I wanted to know half of that, one action divided by 2 is the second action, equals is the third action. So it takes 3 actions on a calculator besides putting in your original value. 15.653, the divide by symbol is one action, Entering the 2 is another action, and pressing the equal key is the third action. Now what if we did is, what did I say, 15.653, one action. We get the same thing with just one keystroke with using the half key. So as I said, the equation solver is basically a calculator on steroids. We might say it allows us to solve equations and does just a couple little extra things. Okay, if you've stuck with me this long, I greatly appreciate it. Just a little bit more I want to go over or point out to you on this Machinist Applets program. We've looked at each of the 8 applets that I've included in there. I would like to hear from you if there's something else that you think could be added to there. You know, I got a little bit of space left on my screen, but I want to go over just a little bit the keypad over here and the buttons down here. As you saw in the keypad, when we select various applets over here, some keys go away and then come back when we select a different applet. Case in point, the plus, minus, multiplication, division, half, square root, left parens, and right parens are only needed in the equation solver. But the equation solver doesn't need the tab and the shift tab. So if we select one of these others over here, we see that these mathematical operators disappear. They're not applicable to this applet. If we select equation solver, we see that they come back, but the tab and shift tab go away. That's, that's just my way of what I did in here to help prevent user error. If we hit down here on this button, reset all, we see nothing is selected now. Nothing is around green. Now if we come over here and hit a key, we get an error message pop up. It says select an entry field first. So how do we select an entry field? We simply select an app. Then that entry field is selected. If we tab, we move to that one. If we tab again, we move on down here. As we see, tab, we move through the various applets. If we back tab, we're setting up here, and we shift tab, we go back through in reverse order. So those are just a few of the things I built in to the keypad. Another thing is, you notice the underlying key in here, these are called hotkeys. So if I come over here to this applet and I choose 11 threads per inch, and I want to compute the travel, as we talked about earlier, I can hit the equal sign, I can hit the calculate button, or on my keyboard I can click Alt-C, that underlined key, underlined character, Alt-C, and that does our computation. Alright, if we leave that there, come down here and do this calculation. Alright, what happened there, I chose an Imperial thread per inch, and I didn't choose one or the other of the internal. So if I try to calculate, it tells me enter either an internal or an external value. And I've tried to do that throughout this app, is trap any errors that would cause would otherwise cause the program to crash. 2.5, calculate. Now let's move down here. Let's just pick some arbitrary values. So we have 1 inch calculates to 25.4 millimeters, so forth. We don't have to clear out a previous applet before we move to the next one. You've seen me several times in here click the reset applet, or in this case Alt S, and whichever one is selected will get cleared. These values are still in here, but if I click the Alt A or click the reset all button, everything gets cleared and any hidden keys come back. So that is, again, just stuff I've tried to build into it to make it user friendly in the event that one day I'll be able to distribute this program. Let me know in the comments what you think about it. Again, if there's another applet that you think might serve a better purpose than any one of the 8 that I've put in, or one that could be done in a little bit of space. As I said in my in the original opening, this is running on a touch screen, and that touch screen is pretty well filled up right now. But I would entertain ideas of other applets that could be included, or could be a second feature in there. I have tried to build in abouts, program name, who I am, the author, the version, creation date, version date. We go back and look at overall instructions. I realize these are too small to read on your screen now, but I've got instructions for each of the applets on here. So again, leave me comments, let me know what you think about it. I've got another program, I've got a couple other Machinist programs that I've written that I'll be glad to show you if there's interest. You guys take care, and I'll see you on the next video.